Radian measure, arc length, and area. So at the beginning of this, you'll notice that we have some diagrams here of examples of radians, measure of angles. So right here, we have our unit circle, and on it, we have our initial array here that has a radian measure, the surface here, see it on the outside. We have the angle in between the two arrays, our terminal side. There we go. A radian measures of angles. Well, here we go. On the unit circle, these are all measured here in radians. And you notice that it also shows you in degrees. So whenever you're solving for specific points on a unit circle, you will need to make sure you're either in degrees or radian modes on your calculator. So whenever we start our circle, we always start at 0 degrees, right? And we go around. And when we go around, we come up to 180 degrees, okay? So whenever we get all the way around in radians, it's pi. Go back all the way and complete the circle is 2 pi, and it's 360 degrees. So these are good points to know. So I would encourage you to memorize the unit circle. It makes it a lot easier. So the radian measures of angles. The radian measure of an angle alpha in standard position is the directed length of the intercepted arc on the unit circle. So you can see it, this image right here is a good example of that. Degree radian conversions. This is good to know. 180 degrees, right, is equal to 1 radian, which is 1 pi. So right here, see it? Okay. So an arc length of a circle. So whenever we're talking about arc length of a circle, let me give me some space. We have the length S. Here's our arc length of the circle. And it's intercepted by a central angle of alpha radians on the circle, and the radius R. So the radius R on here, we can see that it goes from here to here. Here is our formula for solving for the arc length of a circle. The area of a sector of a circle, here is the area formula. It's our alpha times the radius squared divided by 2. So it'd be good and helpful to have this written down in the formula sheet. So when you start solving for these. So let's begin this. Let's start with this first question here. It says, find the missing degree or radian measure. Let me scoot this down a little bit. For each position of the terminal side shown below. We're going to use the degrees between a negative 360 degrees and 0, and a radians from negative 2 pi to 0, okay? And what it is, we're going to find the missing pieces. So we're going to start with the negative 330 degrees. So to do that, we need to get it in radians because it's in degrees. We want it in radians. Well, I'm going to take that 330 degrees and I'm going to multiply it by what I know. For every 1 pi, it's 180 degrees. If I write this in another format, I would say 330 degrees, where pi is on top and degrees on bottom. Let's not forget the 180. When I do that, what happens? The degree reduces. That degree reduces, and it leaves me with pi on top. So that's what we wanted. We wanted in radians, right? That was the whole point. So now I'm going to say negative 330 times pi gives me a negative 330 pi all over 180. And when I divide this out, I find my number that will reduce with them both. And I know that 6 will go into 180 30 times, right? So I can say 6 times 30. I know that 30 goes into 330. So forget the 11 times. So when I reduce, now I see that my 30s reduce, and I'm left with a negative 11 pi over 6, and that's my radians. Okay, so now that I got my answer, what if we have it in radians and I want to know what it is in degrees? We'll do the same thing. We're going to take this negative 7 pi force, and I want pi to go away. I want radians to undo. So I know I'm going to use, I know the relationship between 180 degrees is equal to 1 pi. So I need the pi's to reduce, so I need it on bottom. And if you want to write the word degree, you can, or you can put the little symbol on top. And now let's reduce. Well, I know the pi's reduce. Now what do I have? I have a negative 7 times 180, all divided by 4. And that gives me a negative 315 degrees. So that's converting from degrees to radians, radians to degrees using what we know. Okay, so let's do this next one. This next one says convert the following degree measures to radians. So we have 45 degrees, and we're going to do the same thing. We're going to write down what we have, and we're going to write our needed conversion of what we know. However, we need the degrees to reduce, so that means the degrees needs to be on bottom. And we want it in radians, so we need the pi on top. And now we can go, okay, those symbols reduce, leaves me with pi on top. I got 45 pi over 180, and we're going to reduce this, right? So let's figure out how many times will 45, let's just try 45. 180 divided by 45 goes into it. Let's see, 180 divided by 45 leaves me with 4. So that works out great. If it don't always work out that well, then you can say, oh, it ended in 5. Let's try 5. Okay. This ended in 0. We can try, 5s to reduce. But in this case here, I saw that 45 times 4 is 180, and I was able to just reduce those two. So that leaves me with pi over 4, and that is my answer in radian. So now let's just do the next one. Let's take the out of radian into degree. So I'm going to take that 21 pi over 20, and we're going to plug in our needed conversion, and our needed conversion is to convert this from radians to degrees. So we're going to put what we know. Well, we know for every 1 pi, which is radians, it's equal to 180 degrees. And if you notice, I put the pi on bottom because we want the pi's to reduce. We want to be left with degrees. And now I got 21 times 180 all over 20. But I also know, don't forget the degree, guys. I also know that 20 will reduce, right? It'll go into itself once. It goes into 180. How many times? It goes into it 9 times. So now I have 9 times 21, which gives me 189 degrees. And that's taking it from radians to degrees. So our next one, these are kind of fun, The next one says, convert the following radian measure to degree measures. Use the value of pi found on your calculator. And so they actually want this one here in decimal form. Be sure and read the instructions. They'll tell you how many decimals. We're going to round out to the thousandths on this one. So what I'm going to do is I'm going to take my negative 0.206 radian, and I'm going to use the conversion I know because we want radians to go away. That means the pi needs to go on bottom, and you can write the word radian with it if you want. Reduce it. So Now, what do I have? I have negative 0.206 times that 180 degrees, all divided by pi. So if you can't type it all in your calculator at once, you will need to multiply the top first, then divide by the bottom. Okay, so I know that negative times positive is negative, and then negative divided by positive is negative. So I went ahead and wrote that down. So in my calculator, I said 0.206 times 180 gives me 37.08 divided by pi. So now I'm going to say divide. And in some calculators, you'll have to do shift to use the pi. Some you might have to use mode. And then I'm going to round to the nearest thousandths, which is 3 decimal places. But I'm going to go out 4 so I can go over the rounding rule pretty quickly. So I went out 4. Or let's just go all the way out. As far as my calculator, let me go out. Some won't let you go that far, some will. If we're going to round to the nearest thousandths, that's the 3 decimal places. That means I have to look at the number directly behind it and ask myself, is this number equal to or greater than 5? And if it's yes to either one of them, then we're going to add 1 to this column and drop it all off. If it's no, then we don't add nothing, we just drop it all off. In this case, it's a yes. So that 2 becomes a 3. And this is my final answer. And we got to remember, don't forget your degree mode. All right. We're almost done, guys. Let's do this next one. We're going to do the same thing. We're going to take the degree measure of 76.4 and we're going to put it in radians. And again, we're going to calculate it, round it to the nearest let's round it to the nearest 10 thousandths, which would be 4 decimal places. So we have 76.4 degrees. We're going to multiply it by pi over 180 degrees. Let's mark out my degrees. That's what we wanted, right? So I have 76.4 pi over 180. And in the calculator, if you got a calculator where you can type it all in, it'd be easier. If not, again, multiply the top first and then divide. And I get rounded to the nearest 10 thousandths, which is 4 decimal places. I get this. And this is in radians. All right. It's not bad. So let's do one more and then we'll call it it. So find the length of the arc of the intercepted by following central angle in a circle with a given radius. So you're given this radius and we're giving this angle. So let's solve for it. Well, let's make a statement of what we know. We know that, again, pi radian is equal to 180 degrees. All right, so let's set it up. We are given the 54 degrees. We're going to multiply that by pi over the 180 degrees. Why? Because we're undoing the degrees, correct? And now when I do this, I get 54 pi over 180. And what I'm going to do is go ahead and reduce down. And I get 3 pi over 10. And it's in radians. So my final step is we're going to use that formula because it did talk about the arc. And we want to know the length. So I got, it's a little s. My s was a little big there. That's right, it's a lowercase s times my alpha times my radius. Well, my alpha is 3 pi tenths and my radius is 20. So when I multiply or reduce, if you want to, guys, you can go ahead and put a 1 under that 20. And what do you see? You see that 10 goes into itself once, goes in 22 times. What does that leave me with? 3 times 2, which is 6 pi. And now we're going to stick this in our calculator, 6 pi, and get approximately. And let's round out 4 decimal places. And this is what I get. 18.8496 miles.